Okay, welcome back everybody. We're going to delve into the next installment of ChemQuest 7. We're going to look at critical thinking questions 5 through 8. So last time I taught you guys how to do weighted averages, right? Now we're going to apply the concept of weighted averages to understanding where these numbers on our periodic table, those average atomic masses we've been hearing about, come from. All right? So, let's delve in. So, we have, in this case, it says neon has 3 different isotopes. All right? So, we have 90.51% of neon atoms have a mass of 19.992. Now, if you guys will recall, I told you we need to convert our percent to decimal form, which means we're going to move the decimal 2 places to the left or divide by 100. So this is going to be 0.9051. Okay? Have a mass of 19.992. Now, our next percent that we're given is 0. So this is a really small percent, so I still need to move this 2 decimal places to the left. So this is going to be 0.0027. All right. Have a mass of 20.994 and 9.22%. So we're going to convert that to 0.0922 of neon atoms have 21.991 for a mass, right? So remember, these are different isotopes. They're all neon. They all have the same properties, right? They just have or chemical properties anyways. They just have slightly different masses because of different numbers of neutrons. All right? And what we want to do is we want to take the percent abundance, convert it to a decimal, like we just did, and then calculate our weighted average, right? So in this case, we have 90.51, so we're going to go 0.9051 times 19.992 plus 0.0027 times 20.994 plus 0.0922 times 21.991. All right. Now, again, our smallest isotope is 19.992. Our largest isotope is 21.991. Now, so we should get an average that's in between 19.992 and 21.991. But because 90% of those isotopes have a mass of 19.992, we would expect our answer to come out closer to the smaller isotope than to the larger isotope. All right? And when we do that, right, this times this, plus this times this, plus this times this, I get 20.18 AMU for my average. Okay? Now, for number 6, it says chlorine 35 is one isotope of chlorine. 35 is the mass number. Chlorine 37 is another isotope of chlorine. How many protons and neutrons are in each isotope of chlorine? So Cl35 is going to look like this, right? All chlorine has 17 protons. So chlorine 37 also going to have 17 protons. Okay, if it doesn't have 17 protons, it is not chlorine. Okay, now to get our number of neutrons, we learned this earlier, right? All I'm going to do is take my mass number minus, right? And in this case, I'm going to get 18 neutrons. All right, so 35 minus 17 is 18. So 17 plus 18 is 35. All right. Now, chlorine 37 has a larger mass, and that's not because it has more protons, but that is because it has 20 neutrons. All right, 17 plus 20 makes that number 37. Okay, so if those are our only two isotopes, for example, right, and we did a traditional average of those two, we would guess that the average is 36. Okay, because the midpoint between 35 and 37 is 36. Okay, as we can see right here in chlorine, the average is actually 35.45. Okay, and that happens because there's not the same abundance of each isotope. So we're going to go back, do our weighted averages again for the two isotopes of chlorine. So we're going to change this to 0.75771, right? And we're going to, okay, look at our second isotope, which has a mass of 36.96590. Now, what is our percent for chlorine 37? Okay, well, number 6 told us there's just two isotopes. If 75.771% are chlorine 35, okay, what percent are chlorine 37? Right, it's pretty simple. We're just going to do a little side calculation. The two have to add up to 100%. So I'm just going to go 100% minus 75.771. All right, and I'm going to get 24.229%. Okay, or 0.24229. is going to be the number I'm going to use for that guy. All right, so now that I know my abundance in decimal form for both isotopes, I'm just going to do my weighted averages just like I did for number 5. So I have 0.75771 times 34.96885 plus 0.24229 times 36.96590. And I'm going to get 35.4527. All right. So up here I got 20.18. Down here I got 35.4527. Okay, so for number 8, it says do your answers for questions 5 and 7 agree with the average masses for neon and chlorine on the periodic table. Well, neon's average mass is 20.18. That matches up quite nicely. Chlorine's average mass is 35.45, which matches up there quite nicely. So I'm going to put a big fat yes with an exclamation point, because it's nice when things work out the way they're supposed to.